So, for introduction, kinematic deals with the mathematical description of motion of an object in terms of position. The parameters that will be defined are displacement, average speed, average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. So next 3.2, motion along a straight line or motion in one dimensional. 3.2.1, distance and displacement. 3.2.2, speed and velocity. 3.2.3, acceleration. 3.2.4, different graph of motion. 3.2.5, motion under constant acceleration. 3.2.6, free falling body motion. So next 3.2.1, distance and displacement. So for distance, which is d, is a scalar quantity, while displacement, which is s, is a vector quantity. Distance is defined as the length of actual path between 2 points, which is point A to B with red arrows. The value is 50 km. It covered with distance only. So next, displacement is defined as the distance between the initial point and final point in a straight line. The SI unit is meter, which is m. It covered with distance plus direction. We can see here point A to point B with yellow arrow, and the value is 20 km. So we have a direction here, which is north. So next 3.2.2, speed and velocity. So for this subtopic, speed and velocity, we can know that speed, which is v, is a scalar quantity and is defined as the rate of change of distance. The equation for speed is speed equal to distance over time equal to s over t. It is scalar quantity, so the SI unit is m per s, and dimension is lt inverse 1. So for example, speed, we have 50 meter per second, time with 1 minute, which is 60 seconds. So we use the formula given, which is t equals speed multiplied by time. So 50 meter per second multiplied by 60 seconds. So we get the answer 3000 meters. So speed, only magnitude and no direction, which is speed is scalar. So next, velocity v is a vector quantity and is defined as the rate of change of displacement. Velocity contains speed and direction. The equation for velocity is change of displacement over time interval. V equal to change of displacement or over time interval. So the SI unit for velocity is meter per second. So instantaneous velocity, which is v, is a velocity at any specific instant of time or specific point along the path. So the formula given is v equal to limit the change of s over the change of t equal to ds over dt. An object is moving in uniform velocity if ds over dt equal to constant. So the last one is the gradient of st graph equal to velocity. The gradient of the tangent to the curve at point q equal to the instantaneous velocity at time t equal to t1.
Next, we move to 3.2.3, which is acceleration. Acceleration is a vector quantity and is defined to be the rate of change of velocity over the time interval. The equation of the acceleration is acceleration is equal to change of velocity over time interval. So the SI unit for acceleration is a meter per second time squared. The next is the acceleration of an object is uniform when the magnitude of velocity changes at a constant rate and along fixed direction. So the equation is given like this. An object is moving in uniform acceleration if dv over dt is equal to constant. The next acceleration is a negative acceleration. This term to describe the object that is slowing down its speed. The speed of the object decreases with time. So the gradient of velocity against time graph is equal to acceleration. So next we will move to the 3.2.4, the different graph of motion. So the first one we have the displacement against time graph. So this one it have three types of graph, which is the first one is uniform velocity. Uniform velocity is gradient is equal to constant, and the next one is the velocity increase with time. So the gradient increases with time. So the next one is at point B, the velocity is increased, while at point Q, the velocity is zero because object is at rest, and the next point is point R, which is gradient is negative because the direction of velocity is changing. So the next one is velocity against time graph. It is also have three types of graph, which is the first one is uniform velocity. The gradient is equal to zero, and the next one is uniform acceleration. The gradient is equal to constant because it touch zero, and the next one is when at point A the gradient is positive and the object is speeding up, while at point Q gradient is zero and the object is moving at constant velocity or the object is at rest. And the next one is at the point R when the gradient is negative and the object is slowing down. So this is the formulas where area under velocity against t graph is equal to displacement. So the first one is we have by integrating both sides of the equation. So we have this type of formula, and the next one is this one, and then this one. So this formula is to calculate the instantaneous velocity. Next is the formula where area under acceleration against g graph is equal to velocity. So this is by integrating both sides of the equation. We have this type of equation, and this one is when for the equation instantaneous, and this one is for implies. So
for 3.2.5, it was about motion under constant acceleration. Okay, in the motion under constant acceleration, from the definition of average acceleration, we can get four formula from this definition, which is we get it from the formula of acceleration or uniform acceleration. Okay, for the uniform acceleration, we get A equal to V minus U over T, which is this is the formula of uniform acceleration. So from this formula, we change it to the V equal to U plus AT. Where we get this? We get this from T is multiplied with A and U is going to the left. Okay, so we get V equal to U plus AT. And as we from this graph, this is the graph of time over velocity. So in this graph, we can get the area of trapezium. So this is highlighted as trapezium shape. Okay, from this graph, we can get the formula of trapezium, which is S equal to 1 over 2 multiplied with U plus V multiplied with T. This is from the formula of trapezium. Okay, and the formula of trapezium is going to be the second formula in this subtopic, which is S equal to 1 over 2 U plus 1 over 2 multiplied with U plus V multiplied with T. Okay, and then from this equation, we change the V in this equation into this next equation, which is the V. We take it from the first equation, which is V equal to U plus AT. So we put it in this formula. The V we change it to U plus AT. So this formula equal to S equal to 1 over 2 multiplied with U plus AT multiplied with T. So from this formula, we solve this formula and then we get the third formula, which is S equal to ut plus 1 over 2 at squared. So this is the third formula. For the fourth formula or the last formula in this subtopic is we get it from the first equation and the second equation. As we know, the first equation is V equal to U plus AT and the second equation is S equal to 1 over 2 multiplied with U plus V multiplied with T. So from two of the equations, we put it in here, which is we put V and U at the left and the others at the right. So from the first equation, we get V minus 2 equal to AT. And the second equation, we get V plus U equal to US over T. And these two formula, we multiply it. Okay, so we get this. So when we multiply, it be V minus U multiplied with V plus U equal to AT multiplied with 2S over T. Then from this formula, we solve it and then we get the fourth formula or the last formula, which is V squared equal to U squared plus 2AS. This is the last formula in this subtopic. Okay, so we can use any of this equation well, which is the first formula, the second formula, the third formula, and the fourth formula. We can choose which is the best and is appropriate of the question. Okay, next is 3.2.6, which is free falling body motion. Okay, for the free falling body motion, we have to know four of these main information in this subtopic, which is the first one is the free falling body motion is about vertical motion or y-axis. In the linear motion equation that we just learned now, we learned just now, which is it is about the horizontal motion, which is x-axis. But in this free falling body motion, it is involved of vertical motion or y-axis. Okay, and the second one is G or gravity is known as acceleration due to gravity or free falling acceleration. So in this subtopic, we use G as a free falling acceleration or gravity, which means is the acceleration due to the gravity. Okay, and the third one is air resistance will be ignored in this subtopic. So in the free falling body motion, we doesn't care about air resistance. And the last one is um, the acceleration from the linear motion equation we change into the negative g, which is negative gravity, in every equation. So we not use more acceleration, but we use negative g. We can see it in the formula. There is for formula 2, same with the linear motion equation, which is the first equation is v equal to u minus gt. If in the linear motion equation, the first equation is v equal to u plus at. So this a we change into the negative g. So we get v equal to u minus gt. Okay, for the second formula is s equal to 1 over 2 multiplied with u plus t multiplied with t. And the third one is s equal to ut minus 1 over 2 gt squared. So the a we change into the negative g. And the fourth formula is v squared equal to u squared minus 2gs, which is from this four formula, we can know that there only one formula that doesn't change at all from the linear motion equation, which is the second equation, because the second equation doesn't have acceleration or a in this formula. So the formula that have a only that change into the negative g, such as this formula, the first formula, third formula, and the fourth formula. So for more understand in this subtopic is we see this video. Okay, if in this video I throw the ball into the an air, and then the ball is going up and then is going down back or falling back. This is we can see in this picture. Okay, in this picture we saw the u is going up, and when it was going up, the u is decreased, and at the maximum position v is equal to u, because at this position v is equal to 0. This is the maximum or the last that he will be on the air, the ball will be on the air, and then it will be falling down. When the ball is falling down, the v is increased. So at here we can see there is a height or the s when this happen, which is the u is start from the downstairs here, and then it move up, and then he falling down again, and it was placed in the same place where it was start. So at here h is equal to this is the height, so we can count it from this top, from this under this, and from the bottom, and then the top is the height of this ball have been thrown up, and then when the ball is already falling down, so the s here will be 0. Okay, that's all for me. Thank you.